So our today's session is all about the data acquisition. So I know right now you don't have any real-time data acquisition device, any real hardware. So we'll try to simulate a virtual hardware. We'll try to simulate a virtual hardware and try to learn one channel, one sample data acquisition, and one channel, multiple sample data acquisition. Only two program today will do, and and tomorrow again we'll do the same data acquisition program to understand the data acquisition logic and others very well. So for that you have to open, you have to come into your computer, and you have to come into your type here to search. Now click here and search NIMAX. 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 NIMAX is a short form of Measurement and Automation Explorer. You can say it is a master and it is a brain of all the NI's platform. Okay, using NIMAX you can control the NI hardware. You can configure all the NI hardware and software. You can manage all hardware and software. You can update anything, okay, you want to do with your computer, or you want to uh, change any specifications. So all these things you can do with the NIMAX. If your hardware is not showing in NIMAX, or your NIMAX is not able to recognize the NI hardware, so you cannot able to so that means the drivers and softwares are not properly available on your computer, and you cannot uh, sorry then and you need to install the particular hardware and software. That is the NIMAX. Okay, now in this NIMAX, whatever okay, you can see here when you will open the NIMAX, so you will find this NIMAX like this. In this NIMAX you will get the information. First, my system, data neighborhood, device and interface, skill, software, remote control. You will get these two setup, my compute, my system, and remote system. If you are not getting all these four options, data neighborhood, device interface, skill, and software, that means okay, something is missing. Now today I will show you how can we emulate any NI hardware. So which kind of hardware we want to emulate. So here I am going to show you one basic NI data acquisition card, NI USB 6001. NI USB 6001. In this NI USB 600, it is a small USB based data acquisition device. Okay, and in this NI USB 6001, you will get 8 analog input, 2 analog output, 8 analog input, 2 analog output, and near about 13 digital input output. Now you can see here in this NIMAX, AI0, AI1, AI2, AI3, AI4, AI5, AI6, AI7. 8 analog input are available, 2 analog outputs, and here 13 digital input output. And this system has capability to generate 5-volt DC also. It is a USB DAQ device. Okay. Now in this NIMAX, if you will use this NIMAX, so here I am going to show you one thing. Suppose, okay, there is just a second, uh, pen. Yeah, it is a sensor, and you want to acquire the data from the sensor. So sensor will interact with the physical environment. Okay, sensor will interact with the physical environment, and whatever the sensor you are using, whatever the sensor you are using, the sensor will interact with the physical environment, and it will sense, or it will yes, it will sense the particular physical changes. After that changes, it will generate some stimulus. Okay, some stimulus based, okay, and we want to read that stimulus, we want to read that change, we want to, it will generate some electrical signal. So to read that electrical signal we need a data acquisition device, DAQ. And DAQ has two segments. One is the signal conditioning. In the signal conditioning you will get preamplifier, filter, and then you will get analog to digital converter. All these things you will get. So we need a DAQ system, DAQ, data acquisition system, DAQ system. Then we can get a PC. Using the PC, we can store the here we can store the data. Okay. So it is my PC, it is my DAQ system, and it is my sensor. So based on the sensor's nature, suppose any sensor, any sensor means if you say, sir, Nitesh, I want to measure the LVDT data. I want to measure the temperature. I want to measure the pressure between two water drop. Suppose you are doing experiment here. You are mixing two different mm, liquid, and you want to measure the pressure of this in the border of the liquid, right? So pressure on the water of that particular liquid. So you need a pressure sensor. No matters what sensor you are using. Suppose the sensor's output is a voltage type, then we need a voltage data acquisition device, voltage DAQ. No matters what physical parameters. Suppose LVDT, thermistor, load cell, and pressures, that output is current type. Then you need a current-based data acquisition device. So always it is very important to know about the sensor's output. Okay, based on the sensor output, we choose or we select the data acquisition device. So now, right now, we will try to emulate this DAQ. How it DAQ look like? How this USB 6001 look like? The 6001 look like this. Here you will get that connection pin. You will get the particular connection pin where you can connect your sensor. How can you connect your sensor with the DAQ device? I will share with yes USB 6001. You can follow this video, and using this video you will know how can you connect your sensor and how can you acquire the data. So it is our hardware USB 6001. So today we'll try to emulate this particular data. Today we Today we will try to emulate this particular hardware. Using this hardware, you can connect this hardware with your PC using the Ethernet cable, and you can connect the sensor by using this kind of the wire. Okay, I will share you the various video where you will see how exactly USB cable, yes sir, how exactly we can connect the sensor with the USB cable, sorry, with the this USB 6001. So USB 6001 is a multifunction input output card. It is a multifunction input output card. Just a second. Okay, just a second. Okay, it is a multifunction input output card. So in this multifunction input output card, we got various things. Now in US, sorry, B, sorry, in USB 6001, which I explained 6001 has the it is multifunction input output card. So in this multifunction input output card, we have analog input, so we can measure the voltage between plus minus 10 volt. Any sensor, no matters what sensor you are using, if your sensor's output is voltage type, so you can use this DEC system. It has the analog output, and the range for the analog output is plus minus 10 volt. That means if there is any actuators or any subsystem, any actuators or subsystem or any platform or plant plant whose requirement is the any sinusoidal waveform or DC DC volt under plus and 10 plus minus 10 volt. So you can give that particular value. So this system has capability, which system USB 6001 has that capability. Just a second. Yes, has that particular capability. Using that, you can easily able to yes, you can easily able to acquire the signal from the sensor, and you can easily able to generate the signal and to give any command. And also it has the digital input output, digital input. Okay, so so it has the 0 to okay, 0 suppose it is 5 volt TTL. Suppose we have the 5 volt TTL, so we can generate the 5 volt TTL. We can take the analog input as a 5 volt TTL, or we can generate analog output as a 5 volt TTL. It has the capability to generate PWM. Sorry for the my writing, because I am not that much PWM. So you can use this platform as a counter also. So it is so USB 6001, which I had explained. So that USB 6001 has a multifunction input output card. Sorry, functionality. Multifunction input output function is there. Now you can see here USB 6001 is here. You can take that transmit, and you can give the output and log out and log input and log output. You can connect. Okay, easily you can connect any of the hardware with the USB 6001. So we are talk. You can see here it's showing the specific number of channel analog inputs. Okay. Now one beautiful thing again, which I have to explain. This USB 6001 has 8 analog input. This analog input has eight and four differential. Four differential sensor you can connect at the same time, or 8 single-ended sensor you can connect in the using this DEC system. Okay. Now come here. Okay. After that, let's come into the NIMAX. So in this NIMAX, we will try to emulate the hardware. So for that, you have to come into the device and interface. You have to right click. So when you will right click into the device and interface, you will get a create new. So now simulate NIDAQMAX device or modular instrument you will get. Now finish, and now press the finish button. Now press the finish button. Okay. After that, you will get USB 600. Okay, USB DAQ. Here various options are available, but NI USB 6001 is a USB DAQ. So come here and select NI USB 6001 and press the OK button. In that way, you will able to emulate a NI USB hardware, virtual hardware. This hardware is only present in your computer. It is virtually. Okay, so it will not give you the exact data, but using this emulator, we will able to understand, or we will able to learn the data acquisition programming. Okay, because without any emulator or without any virtual hardware, you cannot learn the data acquisition. So now we had created one NI USB DAQ 6001. If you will right click, so you will get reset, self test, create, rename, delete, hardware configuration, a test panel, and device pinout. If you will click the device pinout, so you will get that particular info about the USB 6001. It will work as a real hardware, but it will not give you a real data because we are not connecting any real sensor. Now you have to come into the your computer, your lab view. Come into the lab view. In this lab view, we will try to write two programs only today. So open your lab view. Come into their computers. Create a folder. Create a new folder. New folder. Okay. Inside the new folder, we'll try to save our data. So come into the lab view, come into the block diagram, and right click. When you will right click, you will get a function palette. Inside the function palette, here you will get the measurement input output. Now you will get NI DAQ max, NI DAQ max. This NI DAQ max Using this NIDQMX, we will able to acquire our data. Now, in this NIDQMX, the first one is create channel. Using this create channel, take a create channel. Okay, using this create channel, we can target our hardware. Using this create channel, we can target our correct hardware. Right now, when you will right, take this function and press Ctrl H, Ctrl H. Now, when you will press click the Ctrl H, so you will get to know. Okay, it is a create a virtual channel. Create a virtual channel to measure a voltage. If the measurement require internal excitation and another, so we can scale it. Now, it is my DAQ create virtual channel. Using this create virtual channel, we can target our real hardware. So what real hardware is available in our computer? That USB 6001 is we had connected USB 6001 with our computer using USB cable. Using USB cable, okay we are able to connect. We had connected USB 6001 using the USB with our computer. Now, so using this, that's first thing. Is using this timing, will configure the okay, particular hardware, and then after that we'll start the acquisition process. After that we'll use this read data, this read read data. Using this read data read function, we can able to read the dynamic data or real-time data or data from the sensor. And after that there is a you can take the stop, wait or clear. So I will take the clear. Using this is a DAQ Max create virtual channel. Using this create virtual channel, we can target our hardware. Using this, we can configure our hardware. Using this, we can activate or start the acquisition process. Using this, we can acquire the signal and it will complete the session. Now, in the create channel, you can see it's analog input voltage RMS, temperature, current, current RMS, resistance, strength, force, pressure, torque, frequency, position, and so many things you can measure using. Okay, so many things you can measure, so many things you can acquire. All this. Okay, so now here press Ctrl H. When you will see in this Ctrl H, so you will find there is task in. The first one is task in, and after that physical channel. This dark one you can see the physical channel. So we need a physical channel. Right click, create, control, physical channel. Physical channel. Physical channel means the real we need to find out the real hardware. Come into the front panel. Here the front panel is here. If I will click here, so the system is giving me device 01 AI. Let's try to check here. Yeah, NI USB 6001. The name is device 0. The name is NI USB 6001 DEV device 1. If you want, so you can rename it. If I will rename it, okay, 6 USB 6001. Let's try to rename again. Okay, here USB USB 6 USB 6001 USB 6001. Can I rename USB 6001? Okay, now you can see USB 6001 I have renamed. Come into the LabVIEW and check. Are we getting just USB 6001 channel number 0, channel number 1, 2, 3, 4, 5, 6, 7, 8, 7. So we are getting all 8 channels here. Why? Because we had connected the hardware. Really, in this condition, right now, truly we don't have the real hardware. We have only the virtual hardware. And we are using that virtual hardware because it is our emulator. Now, using this, we can target our system. Then, after that, again, will put maximum value. Okay, what is the limitation of this computer? So this DAQ system, so that is plus minus. Okay, create control maximum value, create control minimum value, create control maximum and minimum value. So here I am going to put the maximum and minimum value. Minimum will be minus 10 and maximum will be plus 10. Minus 10 and plus 10. Two things has been clear. So using this we can targeting ki dear hardware, okay, dear virtual software, we are targeting a particular hardware and hardware name is USB 6001, and on that USB 6001 we are targeting the channel number 0. From this USB 6001 we are targeting the channel number 0. That's information we are giving to the virtual channel. Why? Using this behavior, using this information, the system will able to recognize the particular resource. Okay, now there's one more, channel configuration. Channel configuration, create control, come into the front panel. In this channel configuration I am going to change something. Now you can see here I am going to use the RSE, reference single ended. Now what we have done, we are giving some information to the this system, our LabVIEW, by using the virtual channel. KTS system, we are targeting a hardware USB 6001, and for that, and that system will measure the data between plus and minus 10 volt, and and the sensor which we are connecting, that sensor is a reference single ended based sensor. Okay, that's information we have given. Now here I am going to correct change the, I am going to target the channel 0. After that, after that, here task out function is there. Take the task out and make a connection like this, task in. In the second function you will get task in or channel in. Same in the first function you will get task out. So let's connect task out of the first function into the task in of the second function. Same, try to connect the error. Okay, if any error will propagate, or if any error will occur, so that error can pass throughout the program, and you can easily able to stop the program. Now in this channel we are going to configure the particular hardware. Here we had opened the working environment of the hardware. Using this information we are targeting a hardware, and we are targeting the particular value. So using this we are targeting the hardware. Now we'll configure the hardware. Now we'll give some info to the hardware. We are going to give the sampling rate, create control, come here. So sampling rate, okay, sorry, sample mode, sorry, sample mode, there is sampling rate, create control, sampling rate, sample mode, sampling rate, and there is one more thing, number of sample, create control. Just a second. Control. Now look at here, using these three functions, sampling rate, okay, it is my sampling rate. What is the meaning of sampling rate? Using this sampling rate, we are giving instruction to the hardware. Dear hardware, you have generated 1,000 sample every second. Every second you have generated 1,000 sample. That means here we are telling ki dear hardware, whatever the data you are getting, you have to cut the data 1,000 times in a second, and you have 1,000 times, and you have to get ready that 1,000 times every time for each and every channel. Suppose one channel means one sensor, one channel means one sensor. Suppose right now we are targeting, okay, one channel means one sensor, not sample. Here we are saying the sampling rate. Using this we are able to target the hardware. Sorry, we are saying ki dear hardware, you have to cut the sample 1,000 times in a second and get ready that 1000 sample for each channel, and you have to work finite time. Finite means you have to work finite means you have to just cut 1000 sample every second, not more than that. Okay, and we will read. Okay, and get ready to read 1000 sample every second. So which is we have done. Now after that, system is ready to work. System is ready to work. Now that now system is ready to work, let's come here. Here, come here. Make a connection like this. Now you can see here, it is my data read analog. Now when you will click here, so you will get analog data, analog, digital, counter, power, and others. Okay, so analog data. In this analog data, single channel or multiple sample, a multiple channel. Single channel means only one sensor you want to acquire. Multiple channel, more than one sample you want to acquire. So single channel and single sample. Okay, single channel or single sample means I have one sample, and whenever I want, I need only one sample. When I will run the program, at that time I need only the current data, only one current data, only one current data. So for that you can take a single channel, single sample, and data in the form of dbl, means numeric. Now now create indicator. It will give you the particular data. It will give you the voltage data. Voltage data. It is my entire program. Now come here. So it is my display unit. Okay, indicators. It's my indicator. Now run the program. So now you can see it is giving me the 30 volt minus 0.30 volt. Now you can see here it is giving me minus 0.30 volt. If I will run the program, so now you can see how much time it's taking. It's taking 1 second to execute. It's taking 1 second to execute. Okay, suppose here if I will take the sampling rate 200 sampling rate 2000, and sample per channel is 2000, sampling rate 1000 and sample. Okay, it's not taking more than sorry, it's not taking 1 second also. Why? Because we are reading only one sample. So when using this, you can able to read minimum, at least minimum one sample. Control R. Sorry. What happened? -1. Okay, not specified. Why not specified? Because we are using the sampling rate. Okay, no conflict. Let's say 10 sample. Okay, no issue. Here we said, dear hardware, you have to cut our data into the 1000 pieces, but get ready 10 sample every second for each channel. Okay, and here we are measuring only one sample once per second. If you want, so you can display this voltage data using this meter. Okay, minus 5 2 plus 5 is my scale. You can display this data in this meter also. Okay, so it is a way to acquire single channel, single sample. We are able to acquire only one sample at a time. When the user will come and user will run the program, at that time the system will give the output. Here I am going to save this program. Save. Okay, I'm going to save this program. One channel, one sample, one channel, one sample, voltage, data. Save it. Clear? Now, suppose you want to store this data. This suppose you want to store this small information. So for that, you can write this program. Open, create, and replace file. You can take, and you don't want to use this open, create, and replace file. So you can use normal program file IO. Come here, take a right measurement file and place here. Now come to the our particular location. So my location is day 13. Inside the day 13, okay, one channel, one sample, voltage data dot vi, not dot data. Okay, change the location, change the sample, change the format, and format I am going to change in Excel type. Excel. I want to acquire the time value also, time value also, and press the OK button. In this way, I can easily able to store my real-time data. You can see here. Now you can see here there's no any uh, Excel file or not any Excel file are available. Run the program. Now you can see one channel, one sample voltage data is available, and you can able to check the data very easily. Clear? So in that way, you can able to store the data. There are so many other way which you can use to store the data. Like if you want, so you can use this open, create, and replace program. You can use this. I'm not going to do this one. Let's copy our previous example, which I explained. Hmm. Read spreadsheet is not there. Just a second. Day 11. Let's come into day 11. Okay. Write text file. Automatically file and folder. Write text file. Let's open this. Okay. This is my program. It is my program. Remove this one. No. Yeah. This program we use? Yes, we can use this program. Now let's see. Control B. Okay. Here I'm going to save this program. Save. And here I'm going to save this program. Save as. Continue in my new folder. Day 13. Save. New folder. Okay. New. Let's try to. Okay. Let's try to copy and paste this program. Let's try to copy and paste this program here. In my data acquisition program. Okay. Here. Let's paste it. Now my data is here. This is my data type. Control B. Right click. Come to string. Take a string conversion. Sorry. Right click. Come into string. Come here. take a fractional string conversion, make a connection like this, make a data output here, right click. Okay, now save this program, save as, come into the front panel, come into the front panel. Error is here. Let's check, let's shift the error here and file type. I'm going to create a text file here. Control small t. Okay, come into 13. Here I am going to run the program. Now new folder automatically created. Inside new data log, I got the new data. Okay, suppose if I will run here, if I will change text to document, run. Now it's created a data log file. If I will change it Excel, so it will create a .csv file we are getting. Now you can see how easily we can able to acquire the single channel and single sample data. Clear, sir? Hmm. It is my previous program.
Sir, this is low level programming, no?
Yeah, low level VI.
Item by item by item, not using any VI.
Yeah, not only one sub VI, high level VI we are using. If you want, so you can remove this high level VI also. Now I want to, now suppose you want to acquire, now you want to acquire the 100 sample every second or entire sample. Suppose today we will discuss about one more time the same. Now in this concern we had targeted USB 6001 or channel number 1 where sensor has connected channel number 1, and the maximum and minimum capability is here. Maximum and minimum capability is here, plus and minus 10 volt. We have given the let the REC, and I want finite sample, means a countable number I want. Here I had given a data. My system sampling rate should 10,000 sample per second. See, dear system, you have to count 10,000 sample every second, and I will read the 10,000 sample, and get ready the 10,000 sample for each and every channel. So sampling rate is 10,000 hertz, and sample to read is 10 kilo. 10 kilo sample is my 10 kilo sample. 10 kilo sample, but sampling rate is 10 kilohertz is the sampling rate which I had fixed here. Now I want all the 10 kilo sample. So for that, come here. Okay, come here. Multiple input. Sorry, single channel. One sample sensor I am using. Multiple sample, and I want to display the data in the array. Right now I want to display the data in the array. Take the data in the form of array. Now you can see here, these indicator will not work. This indicator will not work. Control B, delete this meter, delete this volt data type. We need a array indicator. Come into the front panel, right click, take a numeric indicator here and create an array. Change it into the array. Now you can see here, we can easily able to, okay, now it's clear. Again, multiple channel, one dbl. Here one beautiful things is available along with the deck express. There is a new point automatically come up, that is number of channel per sample. Look at here, create indicator, sorry, create control. Now if you want, so you can take a waveform graph also. and you can connect this waveform graph here. Cool. Okay, now run the program. Now it's taken completely 1 second. Run. Now it will take completely 1 second, and in this 1 second we got the entire 10,000 data. Here in my program we didn't connect that particular waveform with the signal. That's why we didn't get the particular signal here. Let's make a connection. Run the program. You will find that 10,000 samples are present in this particular signal. 10,000 sample, and this and the data log is here. In this data, in this you will get 10,000 data. Now you can see how easily we are able to acquire the data. Okay, suppose if I want to acquire the 10 sample only, 10 sample. So now you can see these are the 10 particular sample. These are that particular 10 particular sample. Okay, 5 sample. So you can easily able to acquire the 5 sample. 100 sample. You will easily able to acquire the 100 sample out of the 10,000 sample. You will easily able to acquire the 1,000 sample. You can easily able to acquire the 500 sample. You can easily able to acquire the 5,000 sample. Easily able to acquire the 10,000 sample. Sorry, 10,000 sample. What if you want to go rigid behind it and I need a 2,000 sample, then 20,000 sample, then I need a 20,000 sample. I need a 5,000 sample, no, 50,000 sample. Suppose here, in place of that sample per channel, if I will 20,000, then you will able to acquire the 20,000 sample here, because dear system, you have to cut 20,000 sample every second, and we will try to read that 20,000 sample every second. So the system should wait for 2 seconds to update. The system should wait 2 seconds. No matters here, I have given the 5,000 sample, because if the system is not able to produce the 50,000 sample, so we cannot read the 50,000 sample. Okay, because here the system's capability, our defined system capability is to generate 10,000 sample, 10,000 sample per second. Sorry, cutting speed is 10,000 hertz. Okay, cutting speed is 10,000 hertz here, and we are looking for 20 kilohertz. Sorry, 20 kilo sample. The 20 kilohertz, sorry, 10 kilohertz is the cutting speed, and we are looking for the 20 kilo sample. That's why it's taking the 2 seconds. No matters if you are giving the 5,000 data, you will not able to achieve your target. Why? Because the maximum capability is 20,000. If I will give the 50,000, if I will write the 50,000, so system will take 5 seconds to acquire the 50,000 data, and after 5 seconds you will get entire the 5,000 data. If I will get the 10 sample, 10, okay, just 10 sample, 10 sample, so system will run very easily, because it can acquire the, because it can cut the thousands, it can cut the 10,000 sample every second. So within a fraction of second you will get the 10 sample. But when your sample will come near about 1,000, 10,000, then it will take 1 second or 5. Okay, it's take completely 5 seconds. Now 10,000 data. Now you can see here the 10,000 data we are getting with a 1 second. If it will be a 2,000 data, so it will take 2 seconds. If it will be a 5,000, 6,000, 5,000 data, so it will take a 50,000 data, so it will take 5 seconds. If here I am going to take the 1 lakh sample, but still I will get only 50,000 data. Why? Because the cutting speed is 1 second. Okay, the cutting speed is 100 kilohertz, and the sample we are looking for the 50 kilohertz. So system will take 5 seconds, and because in our buffer only 50,000 sample is available, so from where we will get another 50,000 data. Okay, so it is a program. Using this way you can able to acquire the data. Using this way you are able to acquire the data. Using this you can save your data. Using this you can also save your data. So it is a my one channel multiple sample program. Save as one channel and sample data, which I can vary. From where I can vary this. I had created this one and I changed this entirely. Earlier it was single channel, single sample DBL. Now, if you are more, if you need more information, so you can convert it into the multiple single channel, multiple sample, okay, waveform. So now here you will get something else, which I will explain tomorrow. Now go and practice till this. So tomorrow we can go ahead and we can acquire some more data. You can work on more data acquisition.